in homogeneous coordinate system, it is not a separate coordinate system, rather it is not a separate coordinate system, rather we can say that it is a bit different way of representing the two-dimensional point. In two-dimensional Cartesian system, any point P is represented by x and y. In homogeneous systems, the same point P, if it is represented in homogeneous system, it can be represented as xh, x is changed to xh, y is changed to yh, and there is a new parameter h, which is known as the scale factor. That means this scale factor means this is the unit using which this xh and yh is measured. Let us take an example. Suppose any point P is represented by 5, 2 in non-homogeneous system, non-homogeneous Cartesian system. It can be represented in homogeneous system as 5, 2, 1. If I consider 1 is the unit, scaling unit by which this 5 and 2 are measured. The same point can be represented as 15, 6 and 3. So, this is measured, this xh is measured in terms of unit 3, and this 2 is measured in terms of unit, this 6 is measured in terms of unit 3. We can also write this is 2.5, 1 and 0.5. So, this is the unit, scale unit by which this x and y are measured. So, this is a different way of representing two-dimensional point in terms of triad xh, yh and h. So, what is the relationship between Cartesian systems and non-Cartesian systems? We can write the relationship between xh and h like this: xh by h is nothing but the value of x, and yh by h is y. So, this is the relationship between Cartesian systems and non-Cartesian systems. So, here 15 by 3 is 5, 6 by 3 is 2. Similarly, here 2.5 by 0.5 is 5 and 1 by 0.5 is 2. Now, with the help of this way of representation of two-dimensional point, let us see how we can represent translation. If we recollect the transformation equations for translation as represented earlier, x dash is equal to x plus tx and y dash is equal to y plus ty. We can write the object point as x dash, y dash and 1. Let us consider 1 is the unit by which x dash and y dash are measured. So, here column matrix is a new term is introduced here, the scale factor. So, here the object point is also represented as x y 1. And what will be this matrix? So, that if you multiply these two, then we will get this transformation equations. Naturally, this will be 1 into x, y component is not there. So, this is 0 into y, there is no y component, and this is tx into 1. So, if we multiply this and this, we will get this transformation equation. Similarly, to get this transformation equation, there is no x component. So, this is 0 into x, this is 1 into y, and this is ty. And to get this third component, we are writing 1, because we are writing the ultimate equations as in matrix form as this, as the matrix equation as this. So, if we multiply these two, we will get these equations, and x dash is equal to this, y dash is equal to this. So, we will get the same thing as non-homogeneous systems obtained earlier. So, this is your object point after translation P dash. This is the transformation matrix TV operated on P. We get the transform point. So TV is nothing but this one, where the specification for the direction of translation is Tx I cap plus Ty j cap. So if this is specified, we can easily obtain TV, and this is multiplied with any object point, we get the corresponding transform point. So this is the homogeneous representation of the matrix equation for translation. Similarly, if we want to convert the rotation in terms of homogeneous systems, we can write that transformation equations x dash is equal to x cos theta minus y sin theta, and y dash is equal to x sin theta plus y cos theta. We can write this in terms of homogeneous system as x dash y dash 1 some matrix 3 by 3 matrix multiplied on object point x y 1. So it will be cos theta into x. This is minus sin theta into y, that is y sin theta, and this component is 0 because 0 into 1 there is no other component, constant terms. Similarly, x sin theta is required, so x and it will be sin theta, and y cos theta, so this will be cos theta, and there is no constant term, so that's why this is 0 and 0 0 1, because the equations are this is for object point in homogeneous system, scale factor is introduced, and the equations will be, final equations will be this. So if you multiply these two, we will get this one. So this is nothing but object point after rotation p dash. This is the rotation operator r with respect to origin through an angle theta operated on p. So again we see that we have represented the transformation in terms of matrix multiplication. And in case of scaling, recall the scaling transformation equation, x dash is equal to sx into x, and y dash is equal to sy into y. So we are representing this in terms of homogeneous system as this. This is the equation. So we can write this as a multiplication of two matrices. This is the operator matrix operated on x y 1. This is x dash y dash 1. So this will be definitely sx into x. This is 0, this is 0, because there is no y component, there is no constant term. Similarly, this is 0 into x, there is no x component here. This is sy 0, and this is 0 0 1. So this is p dash. This is scaling with respect to origin through an scale factor sx sy operated on p, we are getting p dash. So this is the transformations. So we have represented all these three basic transformations: translation, rotation, and scaling in terms of homogeneous systems. And we have also said what are the advantage of using homogeneous systems, because if we want to perform, say, fast scaling, okay, then translation, then rotation, then we will apply in this sequence on P, we are first applying, say, scaling sy, after that translation, say TV, after that, say, rotation r is equal to theta. So, and this will be the final point p dash. So in this way we can just multiply the chain of matrix operator to obtain the composite matrix operators. So in the next class, or we will discuss different types of composite transformations based on these three basic transformations, followed by two more transformations, rotation, these two more transformations, these are mirror deflection and shear. Thank you.